Hello students, this is Miss Dalton. Today's lesson is on finding missing factors and greatest common factors. Just thought I'd throw in a picture of my good looking son there. Just remember, spring break is right around the corner. We can make it. And then summer. So come on, let's get with it. Okay, so we're going to build on the last lesson. And like I said in the last lesson, this is a bridge moving into the new unit, so some of this is going to look familiar. So let's start off with just a question. How would you solve 4x equals 12? Well, I know that all of you know how to solve that. You would divide by 4, right? And that is correct. You would divide both sides by 4, and you would get an answer for x, right? So we would get that x equals 3. Okay, so we all know how to do that. Well, let's take that and apply it to what we're going to be working with today. Now, in this example, 4 and x are what we call factors. They are factors of the 12. 12 is the product or the total. X can be thought of as a missing factor. So as you're trying to solve this problem, you're trying to find out what the missing factor is. So 4 times what missing factor will equal 12. And we can all solve this problem. So let's take this and let's now apply it to the examples that we're going to be working with today. Alright, so in the first example we have find the missing factor. So we have negative 25 x to the 4th y to the 6th equals 5x to the 3rd y times something. So we can think of that like this problem here. We have a factor times another factor, and it equals that product. Well, in this example right here, so we have the factor of 5x to the 3rd y times another factor here that we don't know, and it's going to equal the product right here. So just like you did in the previous example, you would want to divide by what the coefficient of the unknown. So in this particular example, we are going to divide both sides by that 5x cubed y, because we want to find out what that missing factor is. So if we divide the product by the factor, we'll be able to figure out what that missing factor is. This cancels, obviously. So the missing factor is this being divided. Okay, so we're going to take negative 25 and divide it by 5. That gives you negative 5. X to the 4th divided by x to the 3rd. Well, that's going to leave us with 1x on the top. And then y to the 6th divided by y, so that's going to change and be y to the 5th. Okay? So that missing factor is equal to negative 5x y to the 5th. Okay? You can also look at that as what times this will equal that product. Okay? When you multiply them back together, so if I take this right here and multiply it times the answer that I got, then you should get the product right here. Okay? So you can always double check it by multiplying it back. Alright, so what is a greatest common factor? Because we're talking about factors, and now we want to talk about what is the greatest common factor. Now you did this either in middle school or elementary where you were trying to find the greatest common factor of some whole numbers. Okay? Well, now we're going to be working with variables and coefficients. So we need to know what a greatest common factor is. Greatest common factor is the largest term that divides evenly into a set of terms without a remainder. Okay, so when we're working with monomials, we want to be looking at what will go into both of these terms. Okay, so if you look at number 2, we have 56x to the third y squared, and we have 36x to the fifth y. Well, I want you to think of that in expanded form. Okay, so think about how I could factor the 56. All right, so sometimes you might want to make a factor tree. So you want to break it down. Well, the first thing that I think of that would make 56 is 8 times 7. And then if I split up my 8, that would be 2 times 4. Now 7 is prime, so we're going to bring that down. 2 is prime, so we're going to bring that down. 4 can break down into 2 times 2, and then we bring down the 7. This represents all the prime numbers that will multiply together to give me 56. Now, the x to the third, well, that expands out to be x times x times x. And then y squared comes out to be y times y. Okay? Now this down here represents the prime factorization of that term, 56 x to the third y squared. Well, now we need to break down the 36 x to the fifth y. Okay, so let's first break down this 36. 36 is 6 times 6. That's one way to do it. You might have thought 9 times 4. It's fine, however you want to break it down. But keep breaking it down. So 6 times 6 is 3 times 2. And 6, sorry, I said 6 times 6. 6 is 3 times 2. And then another 6 is 3 times 2. Okay? X to the fifth, well, that would be x, 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 x. And then y, of course, would just be y. All right. When you're trying to find the greatest common factor, okay, you're going to look at these both of these prime factorizations. Okay, so we've expanded it out as far as we can. And what you want to do is you want to circle anything that they have in common. Okay, so let's look at this. If you look at the numbers, they each have a 2 in common. So I'm going to circle those. And then they both have another 2 in common. Okay? That's the only numbers that they have in common. Then you want to look at your x's. Well, this one has 3 x's, so I can circle all 3 of those with 3 of these. That's what they have in common of the x's. The y's, we have 1 y here that's going to match up with 1 y here. This is what we call the GCF. So, if I had to write it down, anything that they had in common is a greatest common factor. So, they each had 2 2's, so 2 times 2. They had x, 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 and then they had y. Now, so understand, I'm going back to, and I'm getting just the numbers that I circled, just the numbers and variables that I circled. Okay, now we want to go ahead and multiply that out. 2 times 2 is 4, and then x times x is x to the third, and then we have y. So the greatest common factor that we can divide out of both of these terms evenly would be 4 times x to the third times y. Okay, so that's how you're going to work these problems. Again, remember, the reason why we're doing this is to build up into factoring, because pretty soon we're going to be finding the GCF of a polynomial, of a trinomial, binomial, and we want to take those out. So you got to get good at it now. Okay? All right, fill out your whisk, come to class with your notes filled out in case we do a spot check for a quiz.